This lesson we're going to talk about phase shifts. This is basically just the horizontal shifts left and right. So far we've talked about all the different ones, right? We've done vertical shifts up and down. That was where the midline was involved. Then we've done the vertical and horizontal stretches and shrinks. That's where the amplitude and period were involved. Okay, reflections, we know that. That was that negative out in front. The negative A. And this last one, phase shifts, that's just your horizontal shifts, left and right. And the last little notes that you got, it talked about how to find them from an equation and a graph, but the idea today is that we can graph given that equation. So here's some examples. The main idea with phase shifts is wherever it normally starts, that x value that it starts at is going to change. For example, this point right here on a cosine starts at the maximum, right? And this is where the graph started. But if you look at this new one, this red one, here's that first max. So this is the new start. And what's happened is that the y value stayed the same, but the x value increased to 2. So basically it moved to the right 2. And then just like any shift up or down, the same thing's going to happen with all the other points. So this intercept right here shifts 2 and actually moves to there. This minimum shifts 2, goes to there. This one goes to there. This final one goes to there. So however far you shift off of that y-axis to move either to the right or the left, every other important, the 5 key points, every one of those points is also going to move that same distance. And then if you'll notice in the equation, it happens right here inside the parentheses. That's how all horizontal shifts, left and right, happen, is inside that set of parentheses. Notice, though, that we moved it right 2, and it was a minus in between. So minus inside here means right 2. It's always backwards of what's inside. But the way we learned about solving and finding those phase shifts was to take this stuff inside, set it equal to 0, and that's your actual phase shift. And because it's a positive 2, that means we started at positive 2 instead of at 0. Okay, let's look at another one. This is a sine graph. The red one's the original. The blue one's the new one. You can see that normally it starts here at this guy. There's the start. But this new graph, the blue one, actually started over here at negative pi. So it has jumped from 0 to negative 5. 2 jumps, right? 1, 2. That means this point for the for the original is going to jump 2 points, 2 lines, and there's its new point. Okay, intercept. There's its new point. Minimum on the red, 2. There's its new point. I know this gets muddled. And then the ending point right here is also going to shoot 2 over, and that's where it's going to end now. So the red one changed from this, make it nice and big and dark so you can distinguish it. And then the new one became this. And I mean, you can picture it. If I took that red graph, one cycle of the graph up, and I moved it to the left and set it back down, that's the new graph. The idea is the phase shift is just that amount that you moved. And it's kind of in which direction. But the easiest way to find it is to take that stuff inside, solve for x, and this is your phase shift. That's your new starting point. So instead of being at the 0, 0 point, it would be over here at the negative 5 point. Now looking at this one, I want you to notice a couple of things. First of all, it has been horizontally shrunk, right? You can see that. This blue one went from 0 out here to 2 pi. But this green one has definitely been shrunk down. It started at pi halves and ended at 3 pi halves. So that's definitely not the same period. It's been shrunk down. But it's also been moved. Remember in the other ones, when we had a shrunken, that's the word that would fit best with that. When we had when a period changed on a function, the only thing that happened was it shrunk, but it stayed at that same starting point, right? Same thing with amplitude and stuff. The difference between this stuff, this red one and the green one, is that now it's been moved over. Every point has been moved over as well. So there was not just a period shift, right? Period equals 2 pi over b, meaning its period is only pi now, but it also had a phase shift. 2x minus 11 equals 0. Solve for x. So my new starting point was at x equals pi halves. And that's where this green one, how it moves over here to this point instead of that point. It jumped 2 spots over here to pi halves. So all these other points are going to move the same distance. 2 jumps. All right, so phase shift, that kind of stuff, 2 points, 2 points. So when it comes to graphing, here's what you're going to do. First, identify all your pieces. Get everything pulled from the equation. Amplitude, reflection, period, midline, and phase shift. So for this guy, our A is 3. That's our amplitude. I'm going to write AMP just to make sure we're following the same. Amplitude is 3. It is positive, so there is no reflection. Your period is 2 pi over b, which in this case, b is 1. So my period equals 2 pi. Then I've got a midline. My new midline has been shifted. So it's now at y equals 2. That's a 2, not a 0. Okay, so we've got a shift there. And then finally, this new piece that we're talking about is this phase shift. So the phase shift is going to be everything inside the parentheses, set equal to 0, and then solve for x. So our phase shift is pi. That's our new starting point for this graph. Okay, let's try it for this next one. Here we go. We've got amplitude of 2/3 is again positive, so there's no reflection. Okay, next was the period. So P equals, B is that guy in front of the X, directly in front or out in front of parentheses. So 2 pi over 4, which is pi halves. Then our midline, yes, it has been changed. So our midline is now y equals -3. That's the D. Okay, and then our phase shift, our new element, phase shift, everything inside. So 4x plus 8 pi equals 0. Finish solving. 4x equals -8 pi. Divide. And 4. And we get that x equals -2 pi. And there's our new starting point. There's our phase shift. And then using all these pieces, you can easily draw the graph of them. You just have to remember that there are 5 key points that you start with. Then you apply any amplitude changes, any reflections, and then any shifts up or down, and any shifts left or right. I'm